Hello everybody, my name is Newman and this is going to be a demo of the Comp 6731 project. So this project was done by Newman, Shiyuan, and Erik. So let's get started with the demo. First thing we're going to do is we're going to go into our Git repository and clone our project. So we went into our Git repository, we copied the Git URL, and now we're going to clone it. So git clone and then the URL. Okay, now that we cloned the URL, we're going to follow the README. The README is located in the comp6731 proj. We go in here, we follow the README. So this is just a little bit of a description of the project structure. This is the information that's necessary in order to set up our project. So first, this is just an example. Here, the project is called comp6731, but it's called comp6731/project, but for us, it's going to be called comp6731_proj. So let's change directory into there, comp6731_proj. Okay, and now we have our project in here. Next, we're going to create our virtual environment. So I'm going to create it like this. Basically this command. Okay, now we created the virtual environment we need. Here I'm starting the virtual environment. I started the virtual environment I just created. Next, we're going to install the requirements. The environment got installed. The dependencies got installed. Next, we're going to have to configure some environment variables in order to run this project. Okay, so first thing we're going to do is cd into our dermatology repository. We're going to do an ls, and we're going to see that the dermatology.csv that we use for the first part of our experiment is here. We're going to type pwd. We're going to copy this. We're going to, okay, so before we copy this, we're going to create a new .env file. So let's duplicate it. Copy, paste. So it creates a new one. What we'll do is, let's copy, paste in here. So it's going to copy and paste it in here. So I'm going to then rename this file to .env. This one we don't need. I'll just remove it. And I'm going to put this path here. Okay, and then we're going to do the same thing for heart disease. So let's cd out, ls, cd into the healthcare repository, ls. We see the heart.csv is here. We're going to print our current working directory. And then we're going to update that here. Okay, great. Now we configured the environment variables. Once we create the environment variables, we could go back to the README and see what the next step is. Okay, so we created the environment variables. We did this part to copy it. We updated the paths. This is an example of how the .environment variable should look. And this part we already did, where we activated our virtual environment and installed our requirements. Now, in order to run our demo, we could run it from the root of our project. So we go back one and we're at comp 6731. So the first one we're going to run is our dermatology. So we will just copy this line, put it in here, and run. Okay, so there we go. The program ran. Now we're going to look at some of our results. The first result that we have is our validation accuracy. The validation accuracy is for our cross entropy. Okay, so we could see that with our neural net didn't do its full 100 epochs. We used patience to stop it earlier. It stopped after 35 epochs because of the validation. It wasn't learning anymore. Okay. And then that was with our cross entropy. This is our chart with the DMML loss function. Here we saw that we were still learning, even though we can't really visually see it in the graph. We are still learning by small amounts. So we went to the full 100 epochs, and we see that the validation accuracy is still about the same, a little bit over 0.95. Okay, and now this is the PCA analysis before training. You see the blue points are of class 0, the orange points are of class 1, etc. This is how the data looks before training. Okay, this is how the data looks after we applied DMMLG. You could see that what's important to notice here is that the points are the distances of the classes are being pushed away. Even the classes that were really close together before are being pushed away. You see all the browns are being clustered here. The orange is being clustered here and it's being pushed away. The reds too, you see that they're being pushed away with the DMML. Okay, and now you see the demo, and you see the change with cross entropy. With cross entropy, you see that the clusters are still kind of close together. You see that the points are the classes are still close together, even though they have clustered a bit. Okay guys, now we're going to continue with the second part of our demo, where we're going to show our results with the healthcare cross entropy versus the dense max margin loss function. So we're going to come here in our README and copy this line. Okay, so the training started. Now I will show you the results. The first result is our validation accuracy. You could see that the validation accuracy is a little bit lower with cross entropy and the heart disease dataset. You see it's between 80 and 82. This data set is a little bit smaller than the other one, and we're going to see later in the PCA the classes behave a little bit differently. Now I'm going to show you the validation accuracy for DMML. So DMML, it's actually between 75 and 80. It converges to around 78. It converges to around 78, and we see that the early stoppage happened in both cases. Here, there's an early stoppage around 50. This is the PCA analysis of the data. You see the data is very, very mixed in. The blue and red points are quite intertwined. This is the result in the feature space after we train with DMML. You see that the points are pushed further away. The blue and the red points are not as tied in. You see some small clusters starting to form between the red points that are close together. And you see that the red and blue points, they're starting to be a little bit of space between them. So the points from the different classes are being pushed away. This is the result of training with cross entropy. The results look similar at first, but if we look deeper into the data, we see that even though there's clusters forming between the red points, when classes are close, the red and blue are they're still close even after the training. Like there are clusters forming of the specific classes. So the blues are clustering here, the reds are clustering here, but the blue points are still close to the red points. So even though it's harder to see in this data set, we still see that running DMML pushes the data away compared to just running cross entropy. So that's it. That's it for our demo. Thank you for listening.